I'm going to speak just a bit about the threats that we're seeing, and soon Eyal, our VP product, will take over, and he will show and demonstrate and announce some of the exciting solutions that we're introducing to our end-to-end software security supply chain. Yeah. So security, it was already mentioned in the previous sessions and quite a lot. And I'll show you a secret. We didn't do this just so not to upset the demo gods and have us do 4 or 5 demos in one session, right? We did this because security is natively integrated into what we're doing. We believe in our approach is that it has to be part of the DevOps operating system. It has to be part of how you develop and build and ship, and distribute and run your software. It's not a bolt-on. It's not something you add. It's a foundation that needs to be secured all the way. And Artifactory and JFrog is in a prime position to help you do that. And how, and why, and how, we'll see right now. So let's see. Okay, so when we look at the different, the modern application, we're seeing that we have code, then we take it, build it into binaries. But as we look into the modern application, we analyze millions of different binaries. Most of them are comprised from mostly open source components. There's a very thin layer of business logic that our own developers introduce. There's configuration. And what we are seeing is that our production really runs a lot of other people's code. And we have to trust this code. We have to ingest it into our applications. We have to verify that it hasn't been tampered with. And we need to make sure that we are using the right components. And why? Because as you have shown, this is something that is clearly visible to attackers. Attackers are trying to maximize, just like anyone else, their return on investments, their ROI. They're trying to get as much leverage while staying under the radar, while being stealth. So they understood that if you attack this one developer or this one DevOps manager that has access to how a large software development company is developing its software and has access to different systems that is used to ship those, then they get so much leverage. And that's what they're trying to get. They're trying to get leverage with the minimum effort and steps. So what we're seeing is that while binaries, as Shlomi said, are attacked in production, the attackers have also shifted left. They've shifted left to attack the developers and to be able to inject malicious packages right at the onset, to discover 0 days in that thin layer of business logic that they create, and to exploit CVEs, real CVEs, and we'll talk about real CVEs and overhyped CVEs in just a minute, and exploit them to get access through the open source packages they use. And they are trying to use how we secure resources by protecting them supposedly with credentials, but really when we do so, we expose ourselves by embedding our secrets in binaries, and we'll show examples to that as well. This configuration, that's an attacker's favorite. This one YAML or JSON configuration key value that you forgot to change or didn't make sure that by default is secure. This is what they are looking for. This is a very high ROI. They just misuse that configuration to their advantage. And we have seen tons of examples to that, from misconfigured S3 buckets to Jenkins servers. Finally, tampering of binaries. The tampering of binaries is something that is extremely hard to detect. It requires you to have signing and authentication and auditing through the different stages of the pipeline, because our binaries are flowing through different steps, different machines, different teams, and it's very hard to prove and attest that the binary hasn't been modified throughout the different stages. It's very hard to prove that the binary that I have in runtime is in fact the direct generation or the direct result of the source code that I have and that the configuration it contains that we introduce later is the same. And this is something that attackers take leverage of, they abuse because of the different components, the different open source components that we introduce into the binary, making it a lot bigger and very hard for us to understand what's going on inside. So overall, we're seeing that software supply chain attacks are increasing. This is where attackers are focusing on. This is what they're targeting. And they're targeting developers, which are the clear target. Just yesterday, another example that I've seen of a very popular download manager that appeared to be 3 years to contain malicious code through the attack of its developers. This stuff is happening all the time, and at JFrog, we're focusing a lot of effort from our research team to detect, to find these threats, and then use them to understand what we should be doing, what kind of solutions we need to offer. But one thing that happens is that while developers are the clear target, they also hear a lot about security. They hear a lot about security, and sometimes, many times, they are tired of it. Yeah, I know. I run a product and engineering team. Some of you guys here in the crowd scan us, our binaries all the time, tell us you have this CVE, you have that CVE, you need to fix it, what's the SLA? And we all have this problem. And it gets worse. It gets worse because CVEs is something that is not going anywhere. It's just increasing. More and more vulnerabilities are being discovered, some by threat actors, some by researchers that want to have their day in the sun and find a cool vulnerability in an open source project or in a commercial one. The rate is continuously, constantly increasing, and we have to deal with it. But some of these supposedly critical CVEs are not really critical. We really shouldn't care about them. And I want to give you guys an example. So curl is one of the most popular open source projects ever developed. It's both a command line tool that many of us use. In their website, they claim that anyone that uses the internet uses curl in some way daily. It is installed in over 20 billion different devices, from servers, laptops, all the way to embedded and IoT devices. It's used everywhere, and it does network transfer of the common protocols, HTTP, of course. It's used both as a command line tool and as a library, so it's embedded into other applications. Now, when a critical vulnerability appears in something this popular that is everywhere, it creates a backlash. It creates a lot of work, a lot of hours have to be invested in fixing this. And this is exactly what happened around two weeks ago. So we saw a vulnerability in curl. And this is a tweet by Daniel Stenberg, the author and maintainer of curl. And he said that there's a new vulnerability. Look at this, we're in 2023. The vulnerability is supposedly from 2020. There's a new vulnerability, a critical one. It's 9.8 out of 10. And we need to deal with this because supposedly we've been using the latest version of curl and now it has a vulnerability and it's from 3 years ago. But check this out. What is he saying to us? This is the guy that wrote the code. He's very active in security. It's not like an open source maintainer that doesn't care. He cares deeply about security, understands the criticality of the application he has developed. And he says it's all made up, and he's right. Why? Because this vulnerability is really a bug with no security consequences. Usually when you have a critical vulnerability, it means that an attacker can send some sort of input outside of the application and get it to do whatever they want. Access sensitive data, execute code on the machine this tool is running or this application is running on, something that allows them to do something the software was not meant to for security-related malicious activities. But this only allows you to control how often will curl retry when an HTTP request fails, and it allows you to control it for just a very small difference between what it would have done otherwise. So not really a critical security issue. And indeed, 4 long days after the community agreed. But these are long days where people were trying to find out what is this vulnerability is all about, whether they need a patch. They don't have a patch from the maintainers, so they reach out. They think whether they should decommission curl, whether they should go to another version, but all versions are supposedly vulnerable. And this is always the problem that we have with CVEs. But that's not the only one. Many CVEs, critical CVEs, are real critical CVEs, but in 90% of the cases, the vulnerability is not really exploitable. In any regular and default situation, it's not exploitable. And this was the case with this recent vulnerability. This is something you guys came to us. Some people maybe in this room, but some of our customers remember this ID by heart, because a lot of people that use Spring Boot were vulnerable to this. But in fact, this vulnerability, which is indeed a critical one, it's not an overhyped one, it's just a one that is not applicable in almost all regular situations. It's only exploitable if you utilize some sort of code that is very exotic, and no one ever does that, to answer all HTTP requests with one handler. And also, you need to run on Cloud Foundry SaaS. If your code doesn't run there, then this vulnerability is simply irrelevant to you. Now, this flood, this huge surge in vulnerabilities is a problem. It's a problem because we have to spend a lot of time on this, but also because when we are swamped, when we have to deal with all of this, and these are less of threats, then attackers are coming up with some new attacks. And I want to give you some examples on what they're trying to do. So by far, one of the most common attacks that we're seeing out there is the abuse of secrets in binaries that have been leaked into public repositories from private repositories. We have developed through JFrog Advanced Security a technology that analyzes binaries and source code to find these secrets. And we wanted to test it. So we've downloaded millions of binaries from public repositories. And just like we did it, anyone can do it. Any attacker can do it. There's no need for any credentials, nothing. You just download the binaries. And what we've done is we ran our analysis to see whether we find secrets in those binaries. And we did. Usually what happens is that a developer would push a binary instead to the private registry where they should put the binary, they push it to a public registry or repository. And this was the case with this NPM package. And what you find inside is interesting. You find different sort of secrets. These are just 2 examples. One allowed us to read all of the messages, including direct messages of the Slack application that the company is using, all messages, all of the employee data. And other allowed us to full access to the version control system, in this case GitHub, to read and modify the source code. This is quite amazing findings, and we had to do many of these disclosures, of course, in private and responsibly, to tell that these are active secrets. In fact, we found over 250,000 of these active tokens that are out there and can be abused. The abuse is real simple. If you take the token, you put it to something like curl or any other HTTP client, and you get access to whatever service it is. So, secrets. One other thing that you've heard a lot about is malicious packages. There are so many of them. More and more are being introduced. More and more we're seeing in NPM, which is by far the most common one. But why? Why in NPM? NPM is a very, very popular package manager, and there are many, many dependencies to NPM packages. And these dependencies, when you have so many, it's very easy to hide one among the others. So that's what we are seeing NPM being targeted. But it's not just NPM. So again, the regular joke, we have to talk about machine learning. Machine learning models, they are also being targeted. And when we've decided at JFrog to focus on machine learning models, it was not just to serve them with Artifactory. It was also, as you've seen, to scan them for malicious code. So malicious code in machine learning models. Supposedly, it's just data. Supposedly, it contains data in an H5 file, for example, a pre-trained model. But that model, when you load it, code executes. Why? Well, when we load it, we actually load serialized data that, if in Python, can contain bytecodes through pickle, through other formats. When these is being loaded, then code executes on the data scientist's laptop. And why is that? Because the format allows us to do it. And attackers found this out first. They said, we must go there, we must start introducing machine learning models, and they can do it because these are public repositories, and they introduce the models, they wait for the data scientists to download them. Those data scientists think that it's just data, they load them, and boom, ransomware. So these are some of the attacks we're seeing, but we're also seeing how this trust that we have with AI, with generative AI, is being abused nowadays. So this is an interesting attack. Again, NPM. What we're seeing is that developers ask ChatGPT to help them with building their application that access this graph-based database. And ChatGPT said, yeah, sure, just use this library. The only problem, you can see it on the right, this package doesn't exist. It's simply not there. So what happens? You might say, okay, the developer took this code, copied it, it failed. They said, oh, ChatGPT, it's not really working. Oh, it's not really working. It's not something that we can do it, and we will then just use the package. It doesn't work, it fails, we go over. But attackers are a bit smarter than that. They said, okay, so if this happens to other people and they trust ChatGPT and ChatGPT sends them to these packages, why not take over? So what attackers did is they introduced their own malicious packages with the same name. So when developers will use ChatGPT, they will see these packages and they will use them. So the code will no longer fail. It will succeed, but it will install a malicious package. So this is something that is happening. We're seeing a lot of developers being targeted with the new tools that they're using with AI. But we're also seeing AI introducing vulnerabilities on its own. So when a developer asks, and this is real tools that we've used to generate this, ask for code to be generated to them, that this is a Python code. So when they ask them the generative AI tool to help them build this basic endpoint that responds to HTTP requests, what we're seeing is that it really contains a 0-day. It contains a path reversal vulnerability. And that vulnerability can be exploited by attackers. And even if we ask for a secure endpoint, even if we ask so that the code will have the filtering, it uses a very basic filtering function, which is not really a security function. Those of you that develop Python know this function. It doesn't filter all the different inputs. So it's still vulnerable. This trust is abused. Now, we always look at research, and we have here Shahar Menashe, who is our research manager here, and he's on the booth and happy to talk with you guys, to talk about how we drive with our research, our roadmap, and our product. But we also oriented this towards developer, and Eyal will show this. We try to get all this research data and all of these solutions to talk to the developer. It's focused on binaries. We also utilize the context that you have in binaries to prioritize issues. But there are also issues that are unique to binaries, secrets that are just there when you pack the final binary. And that's something that we strive to find any security vulnerability in there. Finally, you've seen this in the different demos. We are part of the platform. We're natively integrated, natively embedded into each part of how you develop software with Artifactory.